Hey everyone, this is going to be our next lesson, and we are going to be working on graphing linear functions. And again, this is a review from Algebra 1, but we're going to go over some key stuff to make sure that you remember, because it applies to lots of stuff that we're going to be studying in Algebra 2. So here's the standard that we're working on, and I want you to just kind of make sure you pay attention to the fact that we're looking really at key features. Okay, so when we're looking at linear equations, we're going to not really be talking about all of this, but we are going to be talking about increasing and decreasing, which we'll be talking about with other functions. So this is a foundation for what we're going to be doing in the future. Okay, so what you want to be able to do by the end is you want to be able to say that you can graph linear equations from standard form and from slope-intercept form or from their intercepts. So here's some information you want to make sure you remember. When points on a graph lie along a straight line, we call it a linear relation. The other thing that makes it a linear relation is that the variables x and y are both to the first degree. This is a common way of writing it. This specific graph over here is a relationship between x plus y equals 8. And so if you go ahead and you take any point, such as this one, which has coordinates of 2, 4, 5, 3, this being the x and this being the y. If you add that x to that y, you get 8. If you take this point, which is at 0, 8, and you add this x to this y, you also get 8. And so every single point on that line is going to share that linear relationship, which means every single one is points that add up to 8. And that's why we have infinite points, because there's so every single pair of numbers that adds up to 8 makes an ordered pair that's a solution to this function. Okay, so when we're talking about standard form of a function that's linear, we write it like ax plus by equals c, where a, b, and c are all real numbers. They're usually going to be integers in standard form. In other words, this one right here is not standard form because it has fractions, not integers. We also like that first one, that's the coefficient of the x, to be positive. Okay, let's go ahead and we're going to rewrite some equations in standard form. Okay, so what's wrong with this one? Well, remember, the rule says that we want that a coefficient of x has to be positive, or we'd like it to be positive. So what's preventing it from being positive is right now it's negative. So we're going to go ahead and we're going to just do a cheap trick to make this positive. Negative times a negative makes a positive. So if I go ahead and I multiply by -1 on the left and -1 on the right, and then distribute that -1, I get 5x minus 6y, and then -12 times -1 makes positive 12. There's no common factors of 5, 6, and 12 other than 1, so that's our standard form. Okay, now in the second one, the problem was we don't have integers for our coefficients and constant, so we need to go ahead and do that trick that we learned. Well, no, I shouldn't say it's a trick, but go ahead and do something to make each one of those two terms into integers. So we talked before about multiplying by a least common multiple. So least common multiple of 3 and 4, which are our denominators, 3 times 4 makes 12, and there's no integer smaller than 12 that they both are multiples of. So I'm going to multiply everything on both sides by 12. And when I do that, I end up with this. 12 times 3/4. I'm going to do this off to the side. Remember, there's two ways I could do it. I could multiply the numerators, or I could cancel in the problem. But it makes 36/4, which is 9, times x. 12 times 1/3, so I'm just like dividing 12 by 3, makes minus 4y. And 1 times 12 is 12. Now we look to see if there's any number that can divide 9, 4, and 12 other than 1, and there isn't. Although 9 and 12 and 4 and 12 all have common factors in pairs, all three have to have a common factor in order for us to go ahead and do anything else. Okay, so now let's go ahead and take a minute to talk about slope, and then we'll talk about slope and slope-intercept form as well. So when we're writing linear equations, we often write them in slope-intercept form. Okay, and we use M for slope and B for y-intercept. Okay, so we have y equals mx plus b. I don't really use any other forms, so I'm going to ignore that. Okay, slope is the constant rate of change between any 2 points. So if we went back to this line over here and we went ahead and we looked at the ratio of the rise and the run, those 2 points versus these 2 points, it would always be the same. Okay, when we're talking about slopes, we're talking about 4 types of slope, although one technically isn't a slope. We have positive slopes, negative slopes, zero or no slope, and undefined slopes. And they all look like this. Anytime you're reading a line, you always read it from left to right. So in order for it to have a positive slope, as you go from the left side to the right side, it has to be going up. For a negative slope, it has to be going down. For a zero slope, it's like a horizontal line. And for an undefined slope, it's a vertical line. Always remember ski man. Ski man always starts on the left. And so he's going up when it's positive, down when it's negative, across when it's zero, and he will fall off the cliff and perish away if he goes down an undefined slope. Okay, just a couple extra things about slope. Remember, slope is a ratio of rise over run. It also can be written as change in y over change in x. So if we have a positive slope, it's because both the rise and the run are both positive, or the rise and the run are both negative. Negative slopes have positive rise, negative runs, or negative rise and a positive run. No slope, 0 on the top over the run. Undefined slope is rise over 0. Okay, let's go ahead and practice using our equations to graph. So first, remember what format we're in. So this is slope-intercept form. It says our slope is 2/5. Now I'm going to stop for a second and just kind of remember positive and positive means it has to be going which way from left to right. It has to be going like that. 7 represents our y-intercept. So as a reminder, when you're going ahead and graphing, the first thing you do is you find the y-intercept when you're in slope-intercept form, because you have to start from somewhere. So we go 2, 4, 6, 7. We put a point that represents our y-intercept. Then we go ahead and we do rise and run. So remember, rise is you either going up or down, and the run is you going to the right or to the left. Well, in this case, we're going in 2 positive directions. Up is positive and right is positive. But remember, positive slope also comes from being negative. So another way we can do it is we could go ahead and also do it by going down and left, because I don't have any room. So that's what I'm going to do. So I'm going to go down 1, 2, and I'm going to go left. 1, 2, 3, 4, 5, and put a point. And then I'm going to go ahead and I'm going to connect those lines, or points, I'm sorry, to form my line. And then I'm going to remember that I have to put what at the ends? arrows. Okay, so this is the equation graph. Remember, our graph represents all the solutions. In our second equation, what format's it in? It's in standard form. Now, standard form, just by looking at it, really doesn't tell you much. So one thing you could do is rewrite it in slope-intercept form. So to do that, I would subtract x from both sides, giving me 3y is the opposite of x minus 15. And now I would divide everything by 3. And that gives me y. Over here, numerator has a negative 1x, which makes me have a negative 1 over 3 times x minus 5. So I know my slope is negative 1/3. And what does that tell me about my line? It means it's going to be going down from left to right. And then my y-intercept is negative 5. So I'm going to go down 1, 2, 3, 4, 5 to my y-intercept. And then remember, a negative slope says either the top is negative or the bottom. If the top is negative, I would go down. And if the bottom was positive, I would go right. So that means I'm going to go down 1, 1, 2, 3, and I'm running out of room. So I can reverse my directions. From my y-intercept, I could go up 1 and left 3. It's still going to form a line. So now I go ahead and I get my line. And I join those points. And I remember, since it's a line, I got to put arrows because it goes on forever and ever. Now, a quick note about the domain and the range. The domain for most linear equations, the exception being horizontal and vertical ones, is usually going to, it's always going to be negative infinity to positive infinity because it's all real numbers. And the range is also going to be all real numbers. Okay. These are two special cases, horizontal and vertical lines. So remember, vertical goes up and down. And if you can't see it here, let me highlight those lines for you. So here's one, and oops, there's the other. So a vertical line has what kind of a slope again? So if we went ahead and we took any 2 points on there, and I went ahead and I did my rise, take any 2 points and I do my rise, so those 2 points. My rise would be 2, but I'm not going right or left, so my run is 0, which means it's undefined. Undefined is not a number, so technically it's not equal. But it is undefined. So this equation, if I look at it in terms of a table of values, every x value is the same, negative 4. So here, negative 4, 0. This is negative 4, negative 1. This one's negative 4, negative 4. So what it's saying is x is constantly negative 4. And every vertical line has pretty much the same equation, where x is equal to a number that's a constant. So if a vertical line is x equals a number, then a horizontal line probably is y equals. And let's look at the reason. So again, if I take any point that's on here, and I went ahead and did my rise and my rise this time would be 0, and my run would be 2. 0 on the top is okay, so I get my slope as 0. So since I do actually have a slope, because 0 is a number, I would say y equals 0x, and then my y-intercept is where it's crossing the y-axis, which is right here, which is 1. But what's 0 times anything? Well, 0 times anything is just 0, so I end up with y equals 0 plus 1, or y equals 1. And the same thing, if I was to do a table of values, every single y for every ordered pair, like this one here, would be negative 2, 1. This right here would be 0, 1. This one over here would be 3, 1. Every single y is 1. And so every horizontal line always has the same format for its equation, y equals a constant. Okay, and last but not least, just a quick mention, if we have two lines that are parallel to each other, they're going in the same direction. which means the slope of this line, whatever it is, and the slope of this line have to be exactly the same. So slopes of parallel lines are equal, and the slopes of perpendicular lines, remember perpendicular means they meet at a 90-degree angle. So if they're at a 90-degree angle, one is rising, one is going down, means they're opposites in signs, one negative, one positive. And the other thing they are is reciprocals. So they are technically negative reciprocals. Negative reciprocals means if this line here, the slope of this line, is A over B, then the slope of the perpendicular line is the opposite of and flipped. So it's a double flip. It's a way of thinking about it. Okay, thanks.